Alright, so this will be the last topic for the final term. The title is Fluid Mechanics. So fluid mechanics is divided into two parts. So we have fluid statics, and then the other one is fluid dynamics. Okay, so fluid statics deals with fluids at rest. Fluids at rest, or shall we say fluids in equilibrium. And fluid dynamics deals with fluids in motion. Fluids in motion. By the way, class, unsa man ning mga fluids? So matter is divided into four categories. We have solids, liquids, gases, and then we have plasma. Okay. So solids are so compact kaya ang solids such that they cannot flow. So gases and liquids can flow, so they are called fluids. Okay, so we start with fluid statics. So for example, naakay swimming pool and then you fill that with water. So that is an example of fluid or liquid that is at rest. Okay, so nato yung mga physical quantities relating to fluids at rest. Another example, if you have a beaker, if you have a beaker filled with any liquid. So this is an example of fluid that is at rest. Okay? So, kung nakay fluid nga at rest, then we can have some physical quantities that are related to this one. So the first one is density. Density. And then closely related to density is the specific gravity. Specific gravity. I know you have encountered this one in one of your chemistry subjects. Density, specific gravity, and then we have pressure. Pressure. And we can also have the Pascal's principle. Pascal's principle. And then we have the Archimedes principle, which is also known as buoyancy. Archimedes principle. And then we have surface tension, capillarity. So these are familiar terms. Okay? And then for fluid dynamics class, we can define moving fluids through the continuity equation. So these are for fluids at rest, statics. And then for dynamics, we can define or describe the motion of a fluid since nag-move naman siya class na siya velocity. So we can describe it using the continuity equation. Continuity equation, which talks about the flow rate. And then we also have the Bernoulli's equation. Bernoulli's equation. Bernoulli's equation. Okay, so let us tackle each of these. Okay, so let's start with the density. So density is the measure of the compactness of a substance. Okay, so we have the density denoted by the Greek letter rho is the measure of how compact the substance is. A measure of how compact the substance is. Okay. So, tanang objects class kay naa siya unique nga density. So, for example, if naa kay gold o copper, so you can distinguish gold and copper by measuring its density. By the way, you can measure the density of an object by measuring its mass and volume. And then you just have to get the ratio. So we have density is defined as the ratio of the mass and the volume of an object. So for example, kung naa kay gold bar, pwede nimo kuhaon ang mass ani, and then sukdon pod niya nimo iya ang volume. So for example, if this is a rectangular bar, or yeah, so you can get the volume by measuring the length, width, and height of the object. So you can get the density by taking the mass using an analytical balance, or unsa nga atong gamiton. And then we have the volume. Pwede na to kuhaon using a ruler, the length, width, and height. And then if we take the ratio of the mass and the obtained volume, then muna siya ang density sa imong material. Okay, so for example, one of ang isa nga pang-identify og material class nga ginagamit is kining density. Okay? Kay bisan pag unsay form sa imo ang gold, for example, if this is pure, then bisan pag iyang form aning isa is naka-gold bracelet na siya. Kasagarang bracelet no, kay dili naman siya pure. So example na kay pure bracelet nga gold, bisan pag unsa ang form aning gold class, iyang density is the same. Okay? So it is wala siya fingerprint pod sa imong material. Okay? Unique siya for every material. For example, gold has a density equal to 19,000 kilograms per meter cube. So, unsa may meaning ani class? Kung naa kay 1 meter cube of gold, meaning to say naa kay cube nga ang iya ang side kay 1 meter by 1 meter by 1 meter, sorry. It should be a cube. So, suppose this is a cube with side equal to 1 meter. So, 1 meter po ni siya diri, no? Length, width, and height is 1 meter. So, the mass of this cube of gold should be equal to 19,000 kilogram. Okay? So, pure gold, kung kay 1 meter cube ng pure gold, its mass is equal to 19,000 kilogram. So, the unit for density is kilogram per meter cube. You can also use units. The standard units is kilogram per meter cube, and then we also have grams per centimeter cube. In the CGS system, this one is the SI system, and then we can also use grams per ml, since 1 centimeter cube is just equal to 1 ml. Okay. Now, in terms of fluids, kung manotice ninyo class, ang liquid is, although their molecules are farther from each other, parehas sa unlike that of solids, si liquids are incompressible fluids. Incompressible fluids. if we compare this to gases, so the molecules of gases are very far from each other, such that uh, they are readily compressible. So since density is a measure of the compactness or how compact the substance is, and then kini si gas class kay makompress siya dali depende sa temperature and pressure. The density of gases varies. Okay, so for example, the density of air at 20 degrees Celsius is different sa density of air at, for example, 50 degrees Celsius. Okay, so for compressible fluids such as air and any other gases, the density varies with temperature and pressure. Okay, density varies with temperature, temperature and pressure. All right. Okay, and then let us continue with the specific gravity. So specific gravity denoted by specific gravity, which is denoted by Sg. So this is equal to the ratio of the standard, the ratio of the substance with respect to the standard. The density of the substance divided by the density of the standard. So usually, the standard is the density of water at 4 degrees Celsius. So for liquid. For gases, ang ginagamit niya standard is the density of air at 20 degrees Celsius. Okay? So the standard for liquids, liquid is the density of the density of water at 4 degrees Celsius. And then the standard for gases, the air, density of air at 20 degrees Celsius. Okay. So, asa man ni ginagamit ng specific gravity? For example, specific gravity of, say for example, ice or gold na lang class kay kabalo naman ta sa density sa gold. Okay. So the density of gold AU, density of gold is equal to 19,300 kilograms per meter cube. And then the density of water at 4 degrees Celsius is equal to 1,000 kilogram per meter cube. So take note of this because these are constants. And I think in the video class, na-list dito og densities sa mga common materials na ginagamit sa problems. Okay. So therefore, the specific gravity of gold is equal to, we have 19,300 kilograms per meter cube divided by 1,000 kilogram per meter cube. So this is equal to, pila man ni siya class? 19.3. So it has no units. 19.3 ba? Sakto class, no? 193 or 19.3? So it's
19.3, ma'am.
19.3. Okay, thank you. So it's 19.3. The specific gravity of gold is 19.3. And then, for example, kung naa kay ice, the specific gravity of ice, actually class, the density of ice, kay mas gamay siya compared to the density of water. Kung kabantay mo, the density of ice. So just to give you a picture. So you have 900 kilograms per meter cube. And then take note, density of water at 4 degrees Celsius is 1,000 kilograms per meter cube. So the specific gravity of ice, if we calculate the specific gravity of ice, this is equal to it's 900 kilogram per meter cube, and then divided by 1,000 kilogram per meter cube. So this is equal to, pila ni siya ka? 0.9, no? Oh, pila na siya?
0.9,
Sakto
ma'am.
ba? Yeah, it's 0.9, 0.9. Now, kung inyong ma-notice class sa mga, say for example, movies, kung nakakita na mo kuan kanang snow or kanang nagbiyahe mo sa dagat tapos na siya ice. Okay. So for example, kung ano lang class kanang ice cube na nasa tubig. Okay. So if you fill this with water and then butangan siya nimog ice, ang imong mabantayan si ice cube kay mo float, and it is partially submerged in water. Now take note, the specific gravity of ice is 0.9. Actually, kas ang nakasubmerge niya nga part is 90% sa iya. Okay? So, say for example, kini imong ice, ang nakasubmerge nga part sa water is 90%. 90%. And then the remaining 10% is floating. Okay? So, through the specific gravity, you can actually see if an object floats or submerged in water. Let's go back to gold. So the specific gravity of gold is 19.3. Since this is greater compared to 1, okay, this is greater than 1, then gold bar or any form of gold will float in water. Will be submerged in water. Okay? Whereas the ice, which has specific gravity, which is lesser than 1, then it is actually partially floating in water, wherein 90% is submerged in water and the remaining 10% is na lang siya sa surface of the water. Okay? Nakuha ninyo, class? And then, for example, if you have an object that has specific gravity equal to 0.5, then 50% of that object, kung solid na siya, no? 50% of that object is submerged in water and the other 50% is nasa sa gawas. It is partially floating or it is partially submerged. Okay. And then let's go to pressure in fluids. You have questions, class? Pressure.
Wala, ma'am.
So, okay. So pressure is denoted by the small letter p or the lowercase letter p. Okay. Pressure, and generally it is denoted by the ratio of the force and the area. So this force here is the force that is normal or perpendicular to the area that we are exerting with, that it is exerting with. So, for example, in terms of fluid, take note class that pressure is a scalar quantity. It is a scalar quantity, although it is dependent on the force, but we know that the force here is the force that is perpendicular or normal to the area. So we have pressure is a scalar quantity with units of, sa units of sa pressure class. We have newtons per meter squared. Okay. So we have Newton per meter squared. So for example, class, um, pool. So let us change this into pool, swimming pool. Okay. If you might notice, so say for example, this is a 16 feet pool. Now, for example, class, if mo dive ka diri mo dive ka diri. Okay. As you go down the pool, wala kang maglisod, no? Unsa niyo ma-notice class as you go down to the depths of the pool or as you go deeper into the pool, unsa inyong ma-feel? Katry naman na.
Mga ginatulod ka pabalik sa babaw man.
Okay. So makuan gyapon na siya na to, no, ma-discuss na to niya. That is actually the buoyant force. Okay. So murag it is the same thing as kana bitong going up. Kung magsakay ka og airplane, going up to an elevation, uh, naa ba may ma-feel? Or akong mabantayan class kay kanang muadto ko og Cagayan, di kag Bukidnon. Madto kag Cagayan after a very long time nga naa ka sa Bukidnon. Bantay mo anang inyong eardrum kay murag na ay something or bantayan ba ninyo?
Yes, ma'am.
Okay. So that is actually due to the changes in the elevation or the depth. So, saan na siya? Pressure, which is equal to force per unit area. Okay. Let us try to measure the pressure with depth. So for example, as we go down aning swimming pool nga 16 feet, kung magkalalom na kaita, the pressure there, exert sa fluid towards you is actually greater compared to the pit. Okay? Uh, we can actually quantify the change in pressure, and it is equal to the density of the fluid. So say for example, you are swimming in a lake nga na ay nga puro kuan mercury or liquid sulfur or water. Okay. So kining raw diri a class is the density of the fluid, and then multiplied by the acceleration due to gravity, and then we have the change in the height. So y minus y naught, the initial y minus the final position. or this is equal to rho times G times H. Now, take note class nga in terms of fluid, kining rho diri so di ba na ay duha ka object na involved. So the fluid o katong ato ang ipasalom diri. So say for example, ikaw. So this is not your density. Kining rho diri is the density of the fluid. Okay? So take note that rho here is not the density of the object nga atong gibutang diri sa water or sa fluid, but this is the density of the fluid. Okay? So take note that magkadako ang density sa fluid class. May let us search kung pila ang density sa pa yung nailhan nga fluid class. Salt water, for example. So, for example, salt water has slightly greater density compared to that of water since it is not pure na na siya ko ano murag salt puro. Okay, so for pure water, raw H2O equals 1,000 kilogram per meter cube. For seawater, for example, so kung sa swimming pool ka, ang imong ma-experience nga P, slightly gamay siya since gamay man pod ang density sa imong fluid at the same height, no? So at the same height, mas slightly greater ang imong gaka-feel nga pressure as you go deeper because mas gamay man ang imo ang kuan density. Ang seawater, kung naka sa seawater dito ka mag-swim paubos, you have this one, 1013 kilogram per meter cube. Di ko sure ano kasi. Let me just verify density of seawater. Density of seawater. Okay, it's 1026, sorry. 1026. Let me just erase this one. Okay, so it's 1026. So, gamay lang yapon yung difference. 1026 compared to that of water. Okay? Or, we can express this. Pwede siya na to express class as this. So, this is change, no? Change. Change man ni siya. So, we can actually express this as para tagaan siya na itong pangalan. So we have P minus P naught is equal to rho GH. Okay. So, kining P diri or we can write this as P is equal to P naught plus rho GH. Okay. So P here is called the atmospheric pressure. So this is the atmospheric pressure. So the atmospheric pressure is actually equal to, for example, at sea level, it is equal to 1 atmosphere. So atmosphere is another unit of pressure. So Newton per meter cube class is the So, ganito term na Pascal. Okay, 1 atmosphere, or this is equal to, it is a very large number in terms of Pascal. 1.013 times 10 to the 5 Pascal. So this is a very large pressure. So this is the pressure of the atmosphere class at sea level. So for example, what we are experiencing now is an atmosphere, or there is a surface of the earth. We have this one, 1.013 times 10 to the 5 Pascal. So this is around, pila na siya? Abot na siya million class. 1, 2, 3, 4, 5. Around 1013, 1, 2, 3, 4, 5 Pascal. So this is 101,300 Pascal. Okay, so this is a huge pressure. However, manong dili man ta malunod ani nga kadako sa pressure class? Do you have any idea? Although dako kayo ang atmospheric pressure, ang air nga atong gina-breathe kay we have this one. So balikan na nato nga question, no? So we call this the atmospheric pressure, and then this one we call this the gauge pressure. Gauge pressure. Okay. So the same ra na siya katong question na to kaganina nganong dili ta ma overwhelm or dili ta malunod aning ani kadako nga pressure. The same ra na siya sa tire class. Okay. So kung naa kay tire, in order for it to be efficient, tire ba na or kanang interior sa tire, in order for it to be efficient, you have to load it with air that has the same pressure with kung unsay naa sa gawas nga pressure. So kung equal gani ang pressure sa outside o inside, then murag wala kay ma-feel nga kay ma-feel nga anything. So the same with our case, since ang ato ang hangin nga nasa sulod sa tong body ug ang hangin sa atmosphere kay the same ang pressure, then okay ra na siya. So we are inhaling the same air na naa sa atmosphere. So the same ang pressure. All right. So, wala pa na ako na-mention class, no? 1 Pascal is equal to 1 Newton per meter squared. Do you have question, class? Sige lang. Okay, so let's proceed with the Pascal's principle. So, unsa din yung Pascal's principle? Have you heard of the Pascal's principle, class? So, this has a very important kanang application. Pascal's principle. Okay, so according to Pascal's principle, this is a law obeyed by pressure of a fluid at rest. So it says that the pressure applied to an enclosed fluid is transmitted and diminished to every portion of the fluid and the walls of the containing vessel. What does that mean? So for example, usual nga application niya class is this, naka U-shape nga tube. U-shape nga tube. Okay. Kasagara, This is ang iyaang, say for example, this is a circular na siya circular nga cross section. Ang ginabuhat sa uban, for example, this is B, this one is A. A is lesser than B. So the radius of the cross section area is greater compared to the radius of the cross section here. Okay? So for example, mag-exert ko og force that is normal to the cross-sectional area of the tube diri sa pikas nga side. So mag-exert ko og force. Now, this tube is filled with water. So na kay water diri. So kung mag-exert ko og force, according to Pascal's principle, the pressure applied to an enclosed fluid is transmitted and diminished to every portion of the fluid and the walls of the containing vessel. So meaning to say, this, kung apply na to force or pressure diri mo po ni siya ang ma-transmit ng force padulong diri or pressure padulong diri Okay, padulong diri. Any part sa imo ang YouTube. Okay. So, Pascal's principle class, ang iyaang application usually is sa hydraulics. Kanang mag-lift og mga bugat kay nga mga object. Or kanang for example, kanang sa bus. Kung matingala mo, pag pindot sa sa driver sa isa ka button dito, na ma-open na dayon ang door. That is actually hydraulics. Okay? So, Pascal's principle, it allows force multiplication. Force multiplication. So, according to Pascal's principle, P input is equal to P output. Okay, so for example, diri ka nag-input no, tagaan tanig the force here, we call it F1 or F input. And then, ang area ani, we call it area input. And then here, na din kay output force, F output. And then this one, we call this area out. Okay. So according to Pascal's principle, in terms of force and area, we have F over A. So these are for input. And then F out over area out. So take note that the area here is greater. So kini siya nga side, the area is greater compared to the area sa pikas nga side kung asa na to gi-input ang force. Okay. So suppose we want to know the output force. So the output force, F out, is equal to, we just have to manipulate this equation. So we have F input over A input multiplied by A output. Okay, so suppose, na-mention man ako no nga this is a circular cross-section. This has a circular cross-section. So if that has a circular cross-section, the area is equal to, so ito area sa circle class, pi b squared. So in this case, A out is pi b squared. A in is equal to pi a squared. So the radius, A and B. And then this is equal to pi b squared over pi a squared multiplied by F in. Okay, so we can cancel pi out. We have F output is equal to B squared over A squared multiplied by F input. So let us put values here. So suppose F input is equal to 1,000 newtons. 1,000 newtons. So, kung naakay ing ani nga system, mag-input ka og 1,000 newtons. Pila man naka-kilogram ng 1,000 newtons class? Mga around 10 kilos? To ba? Or 100 kilos. 100 kilos divided, multiplied by 9.8 G. It's around, 980, around 1,000. So, mga 100 kilogram lang object ang imong ibutang diri or para maka F input ka og 1,000 newton. And then, let us see kung pila ang F output if A is equal to, say for example, 3 meters, and then your B is equal to 6 meters. Okay. So we have here, padayon lang nato diri class, no? B squared is 6 meters squared divided by 3 meters squared multiplied by 1,000 newtons. 1,000 newtons. So, pila man ni siya, class? You have 36 divided by 9, that is 4. 6 squared divided by 3 squared. Yeah, it's 4 times 1,000. So, this is equivalent to your F out for this setup is equal to 4,000 newtons. So, ang ginabuhat sa, for example, if you want to lift a car, nga pila ka newtons ang kabug-aton, ang imong buhaton class is you just have to narrow this down. Pagamyon kaayo nimo ang cross-sectional area diri Okay? And then diri kay imong padakon. Okay? Para makalift kag heavy objects like that of a car. So, i-push lang nimo ang button, na lang kay gamay nga force nga i-exert diri, push nimo button. Tapos kung dako kay ni siya diri then it can lift very heavy objects. Kuha ninyo. Okay, so muna siya ang application sa Pascal's principle. So say for example, we have here a problem. In a car lift service, 13,000. Okay, so example. We have a car lift service. Tulog lang mo ya. In a car lift service, a 13,300 Newton car. So this is the weight of the car. 13,300 Newtons. Okay. Is placed on a 15 centimeter radius, 15 centimeter radius pipe and is lifted. So we have R sub 2 equals, ganina B akong gigamit class, no? Radius man siya, so we can use R sub 1, R sub 2, R sub 1 for the input, R sub 2 for the output. Okay, so R sub 2 equals 15 centimeter. A small piston is pushed through a 5 centimeter radius. Okay, so your R sub 1 or your R input equals 5 centimeter, 5 cm, sorry. How much force is applied to the piston to lift the car? Okay, so this is just equal to nakay F input over area input equals F output over area output. Okay, so we have F in is equal to A in over A out times F out. So this is equal to pi r sub 1 squared over pi r sub 2 squared. Minsan akong agi class. Multiplied by 13,300 newtons. Okay. Cancel pi out. So we have uh, 5 squared divided by 15 squared multiplied by, sorry, class, 13,300 newtons. So we have 25, let us see. Okay, so the area of, sorry, so the input force is just 1.48 times 10 to the 3 newtons. Now this is just equal to 1480 newtons. So this is much smaller compared to that the weight of the car. So gamay nga input force, makalift na ka og bugat ng car. Kung magamit ka atong piston or katong YouTube nga ano. Okay? So, dili lang sa tataman class. Hmm? Do you have questions?